My name is Janis Putrams. I'm co-founder and CTO at Aerones, and today we're going to talk about a robotic leading edge repair. It's going to be exciting. When the turbine blades were shorter, nobody really cared about leading edge erosion because the tip speed was less, and that was not really an issue. So as the turbines grew, leading edge erosion started to become an issue because tip speeds increased. So companies started looking for solutions, and one of the solutions was 3M tape. And this was one of the early protection methods for leading edge erosion. The surprise there was that it's actually very difficult to get it off. This was one of the topics that one of the early clients said that, guys, can you figure something about this 3M tape removal? It's killing our guys. So that was quite a challenge for engineers. That's what they like, that's what they're good at. So they really, they put their minds to it, and one of the best solutions, what was found, is almost like you take like a rubber and you kind of peel it off. And there's a machine, also quite a powerful machine, which kind of spins this rubber and peels off the old 3M tape. And this very labor-intensive work is now, machine is doing it. So it's not so tiring for person. The person just sits and does some joystick work. And this is like multiple times more efficient and faster. The challenge is obviously in the details. If the tape is applied and there is some bubble left in there, the bubble will be actually the material will not have support underneath it. And then when the rain droplets hit it, as it doesn't have support, there is much more fatigue. And actually the shape will probably not be smooth. There will be like a cavity. And that's a place where the damage can start to progress from. There might be different materials, different best materials for different situations. There are places where, for example, there's a lot of rain, so we definitely want the most enduring material. Even if maybe it's difficult to apply, maybe it's curing a long time, but we would really want to make sure we put the most enduring material because it gets a lot of beating. At other time, maybe we just want a very light material because there's not much rain, but we want to be quick and leave it as soon as possible. There may be other places where, for example, it's very humid. So you have these different kind of situations. Eventually, of course, we are aiming to get to a situation where we can go and do repair any time of the year, any time of the day, any weather, cold, hot, we can go, and we are getting there gradually. We are working with clients to make sure that maybe if the turbine is stopped, it's stopped at the time when the downtime is less costly. So there are different options. Maybe if there's no wind, that's a summertime, that's the typical case. But maybe it's in autumn and spring where there's a higher wind, but there's overproduction. So there's electricity price goes to zero, and maybe that's when we do the repair. So these are different options, what we are exploring with customers. Different turbines might need different kind of repair strategies. The best strategy is actually if we can do a preventive repair. Then the repair can be very quick. The shape of the blade is affected the least, and it can keep spinning. And we apply protection layer so it will last longer. That's the best case. Many times it's not possible because maybe the blade is already on category 3 or 5, or these categories mean the level of damage there is on the blade. One would be a very mild defect, going to the category 5, where 5 is almost as already structural damage, and if it's already category 4 and 5, then we would need to repair the structural, restore the structural strength of the blade first. So we see that as we go to the category 5 and 4 and 5, there's more work. But of course, if the blade needs that kind of repair, that's what we're going to provide. It's good if these inspections are relatively recent, because we had cases where we have visual inspection data we go through, looks good, looks maybe some milder categories, but then we go to the field and it's already maybe half a year later, and we see on the field that actually the damage is much worse than we originally thought. So it's good if the visual inspection is relatively recent. If it's not recent, we can do this visual inspection, but it's always good to do this in advance. The good part with the robot, when it does the leading edge repair, it starts from the tip, whichever process it does, is it sanding or cleaning or the protection layer application, it starts at the tip and it goes non-stop the full length. Because then when the robot goes non-stop, the surface quality and the application quality, we can get it almost perfect. If we need to apply protective coating for 10 meters or 12 or 15, there's not such a difference. It's generally the application itself is just 4, 5, 6 minutes, and maybe if we need to do 5 more meters, it's just another minute. So for robot, the length of repair is not such an issue. Our robots have all telemetry information, so it's not just what's happening on the field, it's also what's happening in office. In office we have supervisors and then project managers, and they can use this all real-time information from the field. So a lot of monitoring, quality inspection, supporting happening from the office with the supervisors. And as the process moves forward, a lot of information is gathered through the process. A lot of video recordings, a lot of quality metadata is recorded. So this is all gathered and stored. And also for a situation like, for example, like after 2 years, something would happen on the farm and, for example, there was a problem with material, we would want to make sure that we knew, like we could make a root cause analysis, like what happened. And then we could go back and see, okay, what was the temperature? Okay, what was the humidity? This is one of the challenges industry has been having. So we think gathering this information is very important because then it allows us to truly investigate things and also make sure that it's done in a proper way. We are looking into robot potentially applying tape if we need to. There's some research going on, and we believe if robot needed to apply this tape, it would be able to apply it in a better quality. We want to achieve good material adhesion because there was a research done by Global Blade Group where they tried different materials, and they really wanted to make sure that they do a proper testing of those materials, not like a laboratory test, but really kind of a real-world application. And after multiple years of research, one of the kind of conclusions, which was very surprising actually, is that sometimes the material itself, the material choice is sometimes not that important. Application quality is the most important, because if the job is done and there's maybe a surface is not prepared properly, it will not have adhesion and the material will not perform according to the kind of specification. And maybe even the manufacturer did some tests and said, oh, the results are very good. In the field, the results might be total disaster just because the surface was not prepared properly. We built a system with robotic hand, which actually does the surface preparation again and again and again and again, like in an automated way. And we look at the sample, I don't know, after like 300 meters, how it's still performing after it has done surface preparation for 300 meters. Is it still good? And when we do this kind of automated testing, then we can kind of be sure that the surface is going to be prepared well. The right way to do leading edge repair is the way where the customer benefits the most. So we need to kind of obviously ask, what's the purpose of the whole repair, right? So what's the purpose of the whole turbine? So the purpose would be to generate electricity and then actually as cheap as possible, right? So either the one who built the turbine gets to profit from the building, or that kind of it trickles down to the electricity costs. When we look at electricity, there's no like, I don't know, tasty electricity or not tasty electricity. It's either there or it's not. So when we flip the switch, either the light comes on or it doesn't. If it does, then the next thing that's interesting us is how much do we need to pay at the end of the month. So, but of course there's actually a third option, a third kind of aspect. We would want that electricity to be from renewable sources. So I would say those are the three aspects. We want to make sure it's consistent, it's reliable, We want the turbines to be a reliable source of energy. We want it to be cheap, because if it's expensive, it will not compete with other sources, and the more efficient we can get wind energy, the more widespread it will become. So that's what we are working for.